Welcome to the second part of our lesson on research design and sampling. In this part, we are going to discuss about the sampling, the reliability and validity, and at the same time, we are going to try to employ this one in our research design. Still, for our objectives, we are going to have the following: familiarize with various concepts in research design, sampling, validity, and reliability. Discuss the different sampling techniques and levels of measurement, apply appropriate research design for the selected research topic, and employ appropriate validity and reliability tests for the selected research topics. So previously we discussed about the different kinds of research designs and also the types of research designs under experimental, survey, and correlational. At this point in time, we are going to discuss about the sampling and participants, and we are also going to tackle topics on reliability and validity. So when we talk about sampling and participants, it is very important that we identify the kind of population where we are going to conduct our research so that from this population, we can identify our sampling frame. And from that sampling frame, we can finally select our samples. And to select our samples, it is very important that we are knowledgeable of the different kinds of sampling design and types of sampling that would be appropriate so that we can answer our research questions with accuracy and our findings would be credible enough to our readers. Okay, so let us now focus our attention to the specification of the population and the sample. So though this is some kind of a review, but it is important that we refresh ourselves on the difference between and among the population, the sampling frame, and the samples. So to recall, when we talk about the population, it is a group of individuals sharing the same characteristics. So like, for example, when we talk about teachers, teachers is a population, and from that population, you might perhaps going to look into the teachers who are teaching special education. So from that population, we are now going to look into our sampling frame or our target population. This is a group of individuals or group of organizations with some common defining characteristics that the researcher can identify and study. As I was saying just a while ago, uh, population refers to the teachers all over the Philippines, say for example. But when we talk about target population, from those teachers, who will be your respondents or participants? So shall we say you are looking for the participants who are teaching in the special education or those who are teaching secondary schools or those who are teaching at the elementary. And this becomes your sampling frame. From the sampling frame, you can now get your sample, a subgroup of the target population that the researcher plans to study for generalizing about the target population. So this sample could be identified using the different kinds of sampling design and the types of sampling. So talking about sampling, again, this is just some sort of a review. So there are two. When we talk about sampling, we have the probability sampling, wherein researcher has an abundance of participants and researcher can select individuals from the population who are representative of that population. On the other hand, when respondents are scarce, then we can employ non-probability sampling, wherein the researcher selects individuals because they are available, convenient, and represent some characteristics that the investigator needs to study. So what are now the types of quantitative sampling strategies that a researcher can employ in his or her study? So we can have the two, the probability sampling or the non-probability sampling, depending on the availability of the participants or respondents that you have. So for probability sampling, we can have the simple random sampling. We have the what we call systematic sampling. stratified random sampling, cluster sampling, or multi-stage sampling. Again, this depends on the kind of respondents that you are looking and at the same time, the availability or the abundance of the sampling that you can reach. Then we can also have the non-probability sampling. These are the convenient sampling, purposive sampling, or we also sometimes call it judgmental sampling because we are looking into a certain purpose. That's why not all are selected. We also have the voluntary sampling, snowball sampling, and quota sampling. Talking about the different kinds of probability sampling, the researcher selects the individuals from the population who are representative of that population, right? So that's what we had discussed in the earlier slides. So when we talk about simple random sampling, the researcher selects participants for the sample so that any individual has an equal probability of being selected from the population. So to do this, usually the researcher would assign a number to each individual or the site in the population. Then he can create a chart or a table that uses random numbers and select the individuals for the sample. This is an example of a random number table wherein each participant is assigned a unique number, and then uh, the researcher would just pick out the certain number, and um, once that number is selected, it will have an equivalent name of a participant. Also, we can have the systematic sampling. So in this procedure, the researcher chooses every nth individual or site in the population until the desired sample size is reached. And so how it is done? Uh, First, the researcher would determine a certain percentage of respondents, say 20% of 1,000 parents in a school. Then the researcher would use an interval, say for example, 1 out of 5 to select the participants. Then the researcher will pick the nth participant. So in our example, this is the every fifth participant on the list until such time that the researcher would reach the 20% of the target population, which in our example, the 1,000 parents in a school. We also have the what we call stratified random sampling, wherein the researcher would divide, so we call it stratifying the population on some specific characteristics, like, for example, the gender, the grade level, or perhaps the socioeconomic status, the education level, and then use a simple random sampling to sample from each subgroup or stratum of the population. So you employ stratification, and then you go back to the simple random sampling on picking your specific sample to a certain population. So how is it done? First, you are going to divide the population by stratum, no? So like what we have said, gender, or in our example here, you are going to divide the population into grade levels. Then you sample within each group in the stratum, like parent in every grade level, so that the individuals selected are proportional to their representation in the total population. So our example here talks about 20% from every grade level. So it will vary depending on the number of population in each grade level. No? So like for example, in grade 1, you have 30 and you are going to get only the 20% of the 30 in grade 2, in grade 3, so on and so forth, considering the number of population, or sorry, the number of samples that you are targeting and also the stratum that you identified. So say, for example, you have here 10,000 participants, or the total population is 10,000, wherein the male is 6,000 and the female is 4,000. And our target sample here is 400. So we just divide 400 divided by 10,000, that will be equivalent to zero point zero 0.04 or 4% of the total population. So we are going to identify the target sample for the male, and that is equivalent to 240, whereas for the female, it is equivalent to 160, considering the 4% of 6,000 and the 4% of 4,000. When you add the two, then it will still be equal to 400. The next one is the cluster sampling. So for cluster sampling, population is divided into different clusters. So based on geography or institutions on, or depending on what kind of cluster um, that is needed in your research. So random clusters are selected and all individuals in the chosen cluster are included in the sample. So how is it done? Say, for example, selecting few schools from a division and including all students from those schools in the study. So we also have the what we call multi-stage sampling. When we talk about multi-stage sampling, it combines multiple sampling methods, may start with cluster sampling, and then using random sampling within chosen clusters. So population halimbawa of at-risk children in the country is quite large. So what the researcher can do is to randomly select school divisions with at-risk students. Then the researcher get a list of at-risk students in each division, and then the researcher randomly selects samples from the student at risk in each division. So somehow you are just doing like this one. Also, you are conducting an inventory of all students at risk across, halimbawa, the Philippines using the different school divisions. Then these school divisions are further divided into school districts. And each school district is further divided into different schools. And from these schools, you are going to identify now the number of at-risk students. Now, then here comes the non-probability sampling. We employ the non-probability sampling because perhaps we have scarcity in reaching our identified population and we only have a few or a little. So the researcher here selects the participants because they are willing and available. So voluntary sampling is also some sort of or a kind of non-probability sampling. So first here is the convenience sampling. So researcher selects participants because they are willing and available to study. So example, surveying students in a classroom because they are readily available. So this one is uh, basing from the convenience for the researcher, at the same time, the availability of the target participants or respondents. Same with purposive or judgmental sampling, wherein the researcher intentionally select participants based on specific characteristics or criteria relevant to the study. Say, for example, selecting only experienced teachers for a study on classroom management. So you have here a purpose, and that is only the experienced teachers. Or, you are judging it because you are actually classifying something specifically one that works with your research. Then we also have the snowball sampling. So researcher asks participants to identify others to become members of the sample. It works like a networking wherein your participant might have someone that shares the same characteristics with the one that you are looking. So it's some sort of asking someone who knew someone who could be a participant on a study. So participants who receive the survey may not be representative of all individuals in the population because you are just quite dependent on the availability of your participants. We also have the quota sampling, wherein researchers divide the population into subgroups, no? So similar to stratified sampling, and then select participants non-randomly until a set quota is reached, no, ensuring that a sample includes a specific number of males and females, say, for example, for a certain research or a certain study, and as long as you reach the quota that you are looking for. So those are examples of what we call non-probability sampling. We also have a different treatment with the non-probability sampling when it comes to data analysis, as we also have a separate set of data analysis tool and operations for those that are belonging to the probability sampling. Uh, Also, before I list it, we also have the voluntary sampling. So when we talk about voluntary sampling, participants self-select to be part of the study, often in response to public call for volunteers. No? So this one is really voluntary, and the um, loophole of this one, in voluntary sampling, is that sometimes you just have too few participants for a certain study. But that's the risk that we need to take. So example of this one is participants responding to an online survey. So like when you throw a survey in Facebook, or in your email, and you are only looking for voluntary participants, then you can call them now as voluntary participants of your study, or we are already employing a voluntary sampling. Now, how do we determine the sample size for your study? As a rule of thumb, according to Criswell, researchers should select as large a sample as possible from the population. As a rough estimate, an educational researcher needs approximately 15 participants in each group in an experiment. So, like for example, if you have a control group and an experimental group, so you have 15 participants for control group, and you have also 15 participants for a the experimental group. For correlational study, approximately 30 participants should be required or is needed, so that you can somehow establish credibility of our results. Again, approximately 30 participants. Then approximately 350 individual for a survey study, or selecting a fraction, say 10%, depending on what is the purpose of your study and how much uh, participants you can take, and how many participants also are available to participate in your study. Approximately, sample size determination should be based on analysis plans and expected outcomes. In short, it is still too dependent to the research questions that you have formulated and the kind of variables that you have identified. So, as a researcher, sometimes you have the discretion on how many participants you are going to employ in your research study. You are the researcher, you know everything that is basically needed for your research, and um, you know that with this kind or number of participants, the results could be justified already. So for sample size consideration, let us consider the adequate size. When we talk about adequate size, you are going to look into the kind of research design that you are going to employ, the statistical power of the research, and of course, the available resources that you can use for your research. Also, you are going to look into the homogeneity or the heterogeneity of your participants. Look into your sampling frame that would cover and that would make your research robust, especially your results. The attrition and non-response rate. So you consider also what is the minimum number of participants that could be credible enough to justify the results or the findings, and you provide an allowance so that if there is an attrition or non-response rates, at least you still reach the minimum number of participants or respondents. Also, very important to note is the power analysis and other statistical consideration like your sampling error. And you may also employ appropriate software or tool like the G asterisk power or simply the G power. So power analysis and other statistical considerations could be the power wherein 1 minus beta is being used, the probability of correctly rejecting the null hypothesis when it is false, or detecting the effect if there is. So we need to also be aware of the power of your research, especially your participants. Of course, you all know this, and we usually employ this one, the significance level or the alpha. This is the probability of rejecting the null hypothesis when it is true. Usually, our common values that we assign is zero point zero 0.05, zero point zero 0.01, and zero point 0.10. Also, the effect size or the magnitude of the effect, because the effect varies by test. For example, we can use the Cohen's d for t-test. Then your number of samples. So it's the sample size or the number of observations or participants, and the power analysis. Typically, it is set at 0.80% or higher, indicating an 80% chance of detecting an effect if it exists. In our LMS, I am going to provide also a tutorial on the use of G-Power and how are we going to use the G-Power in identifying our sample size. So computing sample size using the software like G-Power. So G-Power primarily used for computing sample sizes, power analysis, and effect sizes. So it supports various statistical analysis like the sample size for t-test, for ANOVA, regression, and other statistical analysis tool. Allows users to conduct power analysis for different types of research. And the good thing is, it is free and widely used in educational and social science research. I have here provided the link where you can download the G Power and also a YouTube link for a tutorial on how to use the G Power in identifying your um, research samples. We also have other softwares that help us in identifying our sample size. We have the SPSS or the statistical package for the social science, where the purpose of SPSS is comprehensive statistical analysis software that can also compute sample sizes using plugins or custom scripts. Very important to remember that SPSS uses plugins or somehow custom scripts so that we can identify the number of samples that we are going to use. So it is used for descriptive statistics like regression. It is used for descriptive statistics and also for inferential statistics like regression, ANOVA, and other advanced analyses. Sample size computation may require the use of external macros or tools like the sample power add-on, and it is widely used in educational research for both qualitative and quantitative data analysis. But sometimes, if you are not using the free version, SPSS comes with a price, so you better prepare uh, the money. Now, you better prepare yourself when you are employing the SPSS in your study or identifying your sample size alongside with your descriptive and inferential statistics. We also have the R, although I did not, and I have not tried R and the R packages. So the purpose of R is it's an open source programming language with many statistical packages for computing sample size and conducting power analysis and analyzing data. It features Power, PWR package that allows for power analysis and sample size computation similar to G Power. for various statistical tests. It is highly flexible and customizable for educational research purposes, and it is free and popular in the academia now. We also have the SAS. The purpose of SAS is a comprehensive statistical software suite that can compute sample sizes and perform advanced statistical analysis. It features the following. It can handle large data sets and complex statistical models. It includes procedures like proc power for power analysis and sample size determination, and is commonly used in educational and health research. You also have the PAS, the Power Analysis and Sample Size Software. It is a specialized tool for power analysis and sample size calculation. It features easy-to-use interface with templates for various study designs, supports sample size computation for multiple types of statistical tests, ideal for determining sample sizes in educational experiments or survey and studies. So we also have a lot of other sample size using software like Statistica, Minitab, Stat in CSS, or OpenEpi. No? And also we have available online softwares or online calculators if you want to determine the sample for your research. We have the Rowsoft, no? That is um, popularly used, no? In doing such. So you can also try that one. But if you want to try computing for the sample size manually, you can do this by um, having this formula where n is equal to the required sample size. Then the z there is the z score. The number of standardized deviation and data is from the mean. And the common z scores are the following. For confidence level of 90, that's z equals to 1.645. For 95%, that would be z equals to 1.96. For 99% confidence level, then you have to use, or you are going to use that z is equals to 2.576. P is the estimated proportion of the population, but usually if it is unknown, you can assume it at zero point 0.5. No? So zero point 0.5 for maximum variability, and E is the margin of error, the amount of error that you are willing to tolerate. Like for example, zero point zero 0.05. And if your population is quite small, then you can use adjustment for small populations. If the population is small, you may need to adjust the sample size using the correction formula where um, n with the subscript of ADJ or adjusted sample size is equals to the adjusted sample size, n is the total population, and the small n is the initial sample size calculated using the first formula. Then we are going to proceed now to the instruments. Now we are done with our research design. We identified that we are going to use experimental, or we are just going to use correlational. And then we have identified our sampling and our participants by employing the different sample size calculators, considering the power analysis, the effect size, so on and so forth. Now it is time for us also to consider what kind of instrument we are going to employ. Very important in the instrument usually is its development, which we are going to discuss on a separate discussion. And aside from developing your instrument, you are also going to look into its validity and reliability. And somehow that will be our focus for this discussion. So, what are the criteria or attributes of a good research instrument? So, of course, the first one is it should be reliable. So when we talk about reliability, it means that the scores from an instrument are stable and consistent. It should yield nearly the same result when researchers administer the instrument multiple times at different times. Ibig sabihin that no matter how many times you conduct that one, the result would always be the same, and the students or the participants or respondents would always choose same answer. What are the factors that can result to unreliable data? Ano-ano nga ba? First, questions on instruments are ambiguous and unclear. So there will be instances wherein you will get different answers, not because they do not have knowledge about a certain topic, but rather it is because our questions sometimes are ambiguous or unclear. The procedures of test administration vary and are not standardized. No? So, like, for example, if it's a, say, for example, cross-sectional study, so the way it was conducted in Luzon is different from how it was conducted in the Visayas and how it was conducted in Mindanao. So it's not standardized. So sometimes because of this, the reliability of the instrument is affected. Participants, of course, are fatigued, nervous. They tend to misinterpret the questions, and the usual ones that are happening, they make guesses on test items. No? So they just don't want to think anymore. Rather, they are just going to answer right away. Remember, the wider the variability is attributed to errors of measurement, the less reliable is the instrument. Again, the wider the variability attributed to errors of measurement, the less reliable is the instrument. So we better check our instrument first, especially its reliability, before conducting it to actual participants. The variability of test scores is a function of the degree of precision of the instrument. So if a test score is given 5 times to person, less variability among test scores rather means greater degree of accuracy, and wider variability means lower degree of accuracy. So dapat there should be less variability. In short, dapat the responses of the students are almost the same, because if it's wider enough, then you can really say that it's enough for you to reject your instrument or to consider revising your instrument. That's why also when you are conducting your reliability, it is very important that you also observe certain rules and policies, like the way it will be conducted should be standardized. And at the same time, you should go over your instrument repeatedly, looking into some mistakes or misunderstandings, or tend to have a misconception on the instruction, on the question items, and at the same time on the choices. So, how are we going to measure reliability? So, we have a lot. The first one is, of course, the test retest reliability. And how do we do this? No? So, test retest reliability measures the consistency of results when the same test is administered to the same participants at two different points in time. The researcher administers the test at two different times to the same participants at a sufficient time interval. To determine what is a sufficient time interval is always at the discretion of the researcher, depending on its purpose and its assessment on how long should be the gap, so that you are going now ready, or you are now ready to conduct the set or the test to the participants. If the scores are reliable, then they will relate or will correlate at a positive and reasonably high level, such as zero point 0.6 or higher. So to do it, perform correlation coefficient. So meaning, if you want to measure the reliability using test, retest, then you are going to perform correlation coefficient. We also have what we call internal consistency reliability. It measures the consistency of results across items within the instrument, ensuring that all items intended to measure the same construct yield similar results. Most commonly used statistic is Cronbach's alpha, and a value of zero point 0.7 or higher or above typically considered acceptable. We also have the split half reliability, which measures also internal consistency. You divide the instrument into two halves. Halves, example of this one is odd numbered items, and even numbered items. Then you calculate correlation using Spearman-Brown prophecy formula, and higher correlations indicate better reliability. You also have the Kuder-Richardson split-up test, KR20 and KR21. So this Kuder-Richardson test is used when the items on the instrument are scored right or wrong as categorical scores. No? So it's binary. So right or wrong. Um, what else? Yes or no. The response are not influenced by speed and similar to Cronbach's alpha, but for binary data only. Then also we have the alternative forms reliability, or we also call that one as parallel forms. It involves using two instruments, both measuring the same variable and relating or correlating the scores for the same group of individuals to the two instruments. It needs to be similar in content, level of difficulty, and types of scales because we are conducting parallel forms. So it should be important that we need to consider this specific uh, instruction that it needs to be similar in content, level of difficulty, and types of scale. Conduct both forms to the same group at the same time or in close succession. So pwede mo siyang in a day, you conduct both, or perhaps not really in a day, but should be close succession. Ibig sabihin, magkalapit talaga sila. And also, if you are going to solve now for the correlation of alternating forms reliability or parallel forms, then you are going to employ correlation. Sometimes you also employ the enter-rater reliability. So when we talk about enter-rater reliability, it is used when making observations of behavior. It involves observations made by two or more individuals. Observers record the scores and compare if their scores are similar or different. So ito naman ay somehow qualitative or sometimes it's subjective because the rater could have different interpretation of a certain item or on how they rate. The important thing here is when you are conducting rater reliability, you are looking into the agreements of the raters. It has an advantage of negating any bias because various eyes are looking into the instrument and they can provide valuable informations on how you are going to improve or how valid or sorry, how reliable is your instrument. It requires the researcher to train the observers and requiring them to negotiate outcomes and reconcile differences in observation. So this is the beauty of it. So like for example, if two or three of the observers do not agree on a certain item, they need to discuss it among themselves. What are the considerations why it was not considered as a valid or as a reliable, sorry, not valid, but as a reliable item, and then they are going to negotiate and finally reconcile their differences and suggest to the researcher if the researcher would like to consider it revising or if it would be okay for the raters to accept it as is. So for iterator reliability, you can use Cohen's kappa and the value of zero point 0.7 or above is considered acceptable. Also, interclass, sorry naman. Interclass correlation coefficient are used for continuous data and can assess agreement between two or more raters. So as a summary for the types of reliability, so we have test, pre-test reliability. It is conducted twice at different time intervals, one version of the instrument only, and each participant in the study completes the instrument twice. We also have the alternate forms reliability. Each instrument is administered once, two different versions of the same concept or variable, and each participant in the study completes each instrument. We also have the alternative forms and test-retest reliability, twice at different time intervals, two different versions of the same concept or variable, and each participant in the study completes each instrument. Enterator reliability, wherein instrument is administered once. There is only one version of the instrument, but there are more than one individual that observes the behavior of the participants. Then we also have internal consistency reliability. Instrument is administered once, there is only one version of the instrument, and each participant in the study completes the instrument. So these are the types of reliability that you can employ so that you can establish the reliability of your instrument. So for the computation of the reliability results we have here, if you are conducting test retest reliability, you can have Pearson's or uh, ICC. For split half reliability, you can have Spearman Brown formula. For internal consistency reliability, you can use Cronbach's alpha. For Kudo-Richardson, KR20 or KR21. For alternative forms reliability, still Pearson's R or intra-class correlation. For inter-rater reliability, you can use Cohen's kappa, ICC, or Fly's kappa. Then, after conducting reliability, you can also have the validity test of your instrument. So validity is a sound evidence to demonstrate that the test interpretation matches its proposed use. It is the degree to which all evidence points to the intended interpretation for the proposed purpose. So it measures what it intends to measure. Reliability is for consistency, validity is for purpose. No? So it is um, looking into the proposed or the degree of where all the evidence points to the intended. It measures what it intends to measure. Medyo na-blackout ako dun. Sorry naman. Okay, so steps to employ to ensure validity, we have identify the instrument or test that you would like to use. Look for evidence of validity by examining prior studies that have reported scores and use of instruments. Look closely at the purpose for which the instrument was used in the study. Look as well how the researchers have interpreted the scores in light of their intended use, and evaluate whether the authors provide evidence that links their interpretation to their use. So what are the common forms of validity? So we have content validity, which answers the question, does the instrument covers the entire content area it is supposed to measure? So does it cover all the lessons that you want to measure? Measures through content validity ratio, where experts rate the relevance of each item. And also, we have construct validity, wherein it answers the question, does the survey instrument accurately measure the hypothetical construct or concept it was intended to measure? Can be measured using factor analysis. Yung content, CVI. Yung construct, factor analysis. For concurrent validity, the question that it answers is, does the survey instrument associate with other gold standard measures of the construct or predict a criterion measure? So can be measured through correlation between the instrument scores and another established measure of the same construct taken at the same time. So to look into how we are going to compute that one, usually ang ginagamit lang talaga natin dito most commonly is the face validity and the content validity. No? So for face validity, the best measurement would be expert review and participant feedback on how you are going to improve your instrument. For content validity, you can use the content validity index, where I show here the formula for computing the CVI, using the Losch's formula. For construct, you are going to use factor analysis or Pearson's R because you are going to look into its association with existing instrument. Convergent validity, you can use Pearson's R or Spearman's Rho. For divergent validity, Pearson's R pa din, less than zero point 0.2 and factor analysis. For predictive validity, you can use regression analysis. And for concurrent validity, you can use Pearson's R with external tests. Remember, if scores are not reliable, they are not valid. So scores need to be stable first and consistent before they can be meaningful. The more reliable the scores from an instrument, the more valid the scores may be. However, scores may still not measure the particular construct and may remain invalid. Ibig sabihin, si reliability talaga at si validity should go together because they are both needed to make our research robust, especially our instrument. But, sabi dito, dapat ang isang instrument should be reliable first before maging valid. Although dapat valid and reliable ang ating instrument. So it should always be reliable first and then valid. But a test could be reliable but not valid, especially if it does not measure what it intends to measure. It's just that it's reliable, but it does not cover your research. So mas magandang you conduct the reliability and you conduct the validity and look into the consistency of both the test reliability and the validity. There are types of threat to internal validity of the instrument. And what are these threats? So we have the history, maturation, regression to the mean, selection, mortality or study attrition, diffusion of treatment. So what do we mean when we say history? Because time passes by during an experiment, events can occur that unduly influence the outcome beyond the experimental treatment. So, like for example, you are conducting an experiment on um, teaching methods or classroom experience. Eh, biglang pumutok yung bulkan sa lugar na yon. So, it might affect on how the students would respond to your research now. So, in response, actions the researcher can take are the following, or for the history, the researcher can have both the experimental and control groups experience the same external events. Ayan. So, dapat nakakontrol yan. Maturation. Participants in an experiment may mature or change during the experiment, thus influencing the results. So, like, marami na silang nalalaman dahil na-expose sila sa mga konsepto or di kaya tumanda na sila, no? So, to avoid this one or to respond to this one, the researcher can select participants who mature or change at the same time. Then we also have the regression to the mean. So participants with extreme scores are selected for the experiment. Naturally, their scores will probably change during the experiment. Scores over time regress toward the mean. So our researcher can select participants who do not have extreme scores as entering characteristics of the experiment. So dapat uh, nasa the same scope sila, no? Nasa the same level of cognitive para wala tayong mangyayaring regression to the mean. Selection, participants can be selected who have certain characteristics that predispose them to have certain outcomes. So perhaps they are brighter, so expect mo na talaga na tataas halimbawa yung result mo. So the researcher can select participants randomly so that characteristics have the probability of being equally distributed among the experimental groups. Then there comes mortality, or also called study attrition, wherein participants drop out during an experiment due to many possible reasons, and the outcomes are thus unknown for these individuals. So may mga missing cases ka na. So to answer this one, a researcher can recruit a large sample to account for dropouts or compare those who drop out with those who continue in terms of the outcome. So Ang pagkakaroon ng marami naman kasing sample is dependent on the availability of your participants. But if not, then what you can do is compare those who drop out with those who continue yung kanilang results. Also, we have diffusion of treatment, no, wherein participants in the control and experimental group communicate with each other. This communication can influence how both groups score on the outcome. So the researcher can keep the two groups as separate as possible during the experiment. Ito yung parang nagchichismisan sila. So like, si teacher ang gumanito sa amin, so baka gagawin din nila yan sa inyo. O parang ganun. So dahil dyan, nagkaroon ngayon ng contamination of groups, no? The control group and the experimental group. So these are the things that we need to address so that you can really say that your instrument and your is valid, and at the same time your research in totality is valid and credible. uh, Also, we have compensatory or resentful demoralization. So the benefits of an experiment may be unequal or resented when only the experimental group receives a treatment, no? So like, identify nila na, oh, okay, bakit sila may ganito? Bakit sila inimplementa bakit si teacher nag-implement ng ganito sa kanilang section, sa amin hindi? So it's a resentful demoralization. So the researcher can provide benefits to both groups, such as giving the control group the treatment after the experiment ends or giving the control group some different type of treatment during the experiment. So may intervention sa kay group A, sa control group, may intervention din kay group B. Or, sabi dito, para walang demoralization, after ng yung experiment, yung intervention in-implement mo kay Group A, ay i-implement mo na rin siya kay Group B. Yon. Then, compensatory rivalry. No? Participants in the control group feel that they are being devalued as compared to the experimental group because they do not experience the treatment. Ito naman, selosan. No? Kasi, bakit ganito sa kanila? Sa group 1, sa section 1, bakit sa amin hindi? So to address this one, the researcher can take steps to create equality between the two groups, such as reducing the expectation of the control group or clearly explaining the value of the control group. So papaliwanagan natin ngayon yung control group natin. Then testing, participants become familiar with the outcome measure and remember responses for later testing. Ito yung naalala nila yung, okay, ito yung sinagutan namin last time, so itong sagot dito. Or ito yung naging sagot ko dito. So to address this one, the researcher can have a longer time interval between administrations of the outcomes or use different items on a later test than were used in an earlier test. So you can change the item, but it should not change the competency that you are measuring. Or, yun na nga, para makalimutan nila, you can have the post test sometime uh, on the later part of the month. Like, meron talaga siyang gap na makalimutan nila yung mga sagot nila. Instrumentation, the instrument changes between a pretest and post-test, thus affecting the scores and the outcome. Ito naman yung pagka masyadong nagbago yung pretest ay yung post-test mo doon kumpara sa iyong pretest. So here, the researcher can use the same instrument for the pretest and post-test measures. So ensuring that they are parallel but they are not identical. No? Also, we have the threats to external validity. So kanina internal validity of the instrument. Ito naman, um, external validity. So ano ito? Mga interaction of selection and treatment, interaction of setting and the treatment, interaction of history and the treatment. No? So because of the narrow characteristics of participants in the experiment, the researcher cannot generalize to individuals who do not have the characteristics of participants. So here, the researcher restricts claims about the groups to which the results cannot be generalized. The researcher conducts additional experiments with groups with different characteristics. Ito yung pwede natin maging address doon sa interaction of selection and treatment na threat. Second, for setting and treatment, because of the characteristics of the setting of participants in an experiment, a researcher cannot generalize also to individuals in other settings. So dito naman, in-emphasize natin yung konteksto ng bawat sample natin. The researcher needs to conduct additional experiments in new settings to see if the same result occur as in the initial settings. So like for example, a konteksto ng mga Filipino sa Luzon o Filipino sa Visayas and sa Mindanao. For history and treatment, because results of an experiment are time-bound, a researcher cannot generalize the results to past or future situation, meaning it is true during that time kung kailan siya kinandak. It could not be true before or for relating to the past or to the future. Kasi nakandak mo siya during that time, so naging valid siya during that time. The researcher needs to replicate the study at later times to determine if the same results occur as in the earlier times. So ito yun. Para ma-ensure natin na okay, tama pa din ito, you can replicate that study sometime in the future. So para masabi natin na ito yung result na before when I conducted this one, ito yung results ngayon when I conducted this again. Para ma-address din natin itong threats to external validity of your research. Ito naman is just a simple review of the variables and measurement. So here, um, when we talk about types of measurement, we have categorical scales and of course, the continuous scales. So sa categorical scales naman, we have nominal and ordinal. Sa continuous scales naman ay we have interval or quasi-interval and ratio. So this is an example of a research instrument that has nominal scale, like say for example, how much education have you completed? So no college, bachelor's degree, what is your class rank, freshman, junior. So these are example of nominal scales. When we talk about ordinal scales, it uses categories that imply or express the rank order. So like for example, for this one, has your advisor helped you select courses? So not at all, to some extent, to a very great extent, so on and so forth. Or you can rank a preference for type of graduate level instruction from 1 to 4. Ganyan. So meron tayong pina-follow na rank. The cost interval or interval ratio scale uses continuous equal intervals. So like for example, school is a place where I am thought of as a person who matters. So strongly agree. So meron tayong dyang equivalent scale. No? So our colleges and universities should conduct research to solve economic problems. So we have here also a scale to equate with that kind of qualitative um, statement. So for nominal scales, provide response options where participants check one or more categories that describe their traits, attributes, or characteristics. So like for example, um, gender, yes or no response, or the semantic differential. No, like for this one, very alert, quite alert, some alert, neither, some drowsy, quite drowsy, very drowsy. It's an example of a semantic differential scales. No, so what we do here is that we just assign a number to a certain category, no, or a certain kaya tinawag siyang nominal scale. Wala talaga siyang actual value. Of course, as ordinal scales provide response options where participants rank from best or most important or to worst or least important some trait, attribute, or characteristic. So, halimbawa nito ay mga attitudinal measures like highly important to of no importance or the extent like a great extent to a little extent. So, what makes it different from the Likert scale? So, sometimes ordinal scales are misinterpreted as Likert scale. Sorry, not as Likert scale, but as quasi interval. So later in the slides, you will know when to use this kind of attitudinal measures or extent and make them as um, interval or quasi-interval scales. So interval or ratio scales, interval scales, rating scales, or continuous scales provide continuous response options to questions with assumed equal distances between options. So these scales may have 3, 4, or 5 responses. That's just like the Likert scale, which theoretically assigns equal intervals. So it has become common practice to treat Likert scale as a rating scale and assume the equal intervals hold between the responses or the response categories. Kaya mako-consider natin si Likert scale as an interval scale. Yun. So for the Likert scale, in order to treat Likert scale or Likert data as interval data, researchers should develop multiple categories or choices in their scale. So what are these? You should assign. Determine whether their data are normally distributed, and establish whether the distance between each value on the scale is equal. Otherwise, they should be treated as ordinal scales for purposes of data analysis. So for ratio scale or the true zero scale, it is a response scale in which participants check a response option with a true zero value and equal distance between units. So example are height or income levels. We also have the combined scales. So quantitative investigators often use a combination of categorical and continuous scales. Interval scales provide the most variation of responses and lend themselves to stronger statistical analysis. Rule of thumb: if you do not know in advance what statistical analysis you will use, create an interval or continuous scale. Continuous scales can always be converted into ordinal or nominal scales, but not vice versa. So you always treat your data as if they could be a continuous scale rather than assigning them or defining them as ordinal or nominal scale. So yeah, these are just examples of variables and how we classify them and according to their scales. So as a summary of discussion, so not this afternoon, but in this session, we discussed about the research design, the sampling of participants, and selection of participants, also the validity and the reliability of instruments, and the different levels of measurement. For your activity, you are going to develop now the research design, sampling of your participants of your identified research. Let me repeat that one. Develop the research design and sampling and participants of your identified research study for our presentation this coming Saturday. Yeah, so with that, I thank you for listening to this session and hope to see you again on our succeeding sessions. Have a blessed day. God bless everyone.